As we continue our learning journey with administering virtual networks, let's move into the topic of administering network traffic. This module will cover key areas such as configuring Azure Load Balancer, configuring Application Gateway, and configuring Network Watcher. We will begin with an introduction to Azure Load Balancer. Next, we will delve into Azure Application Gateway, focusing on its role in balancing web service traffic and HTTP/HTTPS traffic. Finally, we will cover Azure Network Watcher, a powerful tool for monitoring and troubleshooting Azure network infrastructure. By the end of this module, you'll have a better understanding of these essential Azure services and their application in managing network traffic effectively. So let's get started. Let's start talking about Azure Load Balancer. If you're looking for a solution that can help you effectively manage your traffic coming into your network to a group of resources, typically a backend pool of virtual machines or other services, then in that case, you're looking for a solution called Load Balancer. Now, Azure offers us 4 different types of solutions to look at load balancing in our environment. We can start off with talking about Load Balancer. Now, typically, this is a solution that you might use to balance traffic that's typically based on TCP, UDP protocols, and you are looking to balance that traffic on a backend pool. However, if your solution requires a little bit more than that in case of handling traffic that's based on HTTP, HTTPS based, then you might be looking at a different solution, a solution like Application Gateway. However, there are a couple of other solutions that we can talk about, things like Front Door and Traffic Manager. Now, the Front Door solution typically is used as a content delivery network solution. If you have worked with any of the similar services that are available on the internet that provide you solutions like media services, so you can gain access to resources from anywhere in the world, however, still get that data or the media streaming to you much faster, much quicker. In the backend, they might be using a content delivery network, which simply means that they can bring the data closer to the end user much quicker by using the backend network. For this example, using Microsoft Backbone Network to bring that data closer to the end user and then passing that data over to the user. Now, in this scenario, we could use Front Door as a solution for that scenario. Now, if you're looking for a DNS-based solution, in that case, you might be looking at a traffic manager that can handle that for you. If you are looking to divert traffic based on DNS names and you want them to be resolved very quickly to your backend resources so your end users can get the results that they're looking for, then Traffic Manager would be a solution for you. Now, before we go into a little bit more detail around some of these solutions, let's have a quick understanding on how can I understand which solution works best for me. Now, for this part, let's have a quick look at the documentation for Azure Load Balancing solutions on a Learn portal that we have. Now, for us to do that, I'm going to go into learn.microsoft.com and start looking for the documentation for load balancers. As I see some of the results coming up here, all I'm looking for is finding out some load balancing solutions. And when I land onto the load balancer documentation, we're looking for load balancing options to pick from. Now, this documentation is quite good. It talks about all sorts of different things that we can do with 4 different options that we have within our environment. For example, the Front Door, the Traffic Manager, Application Gateway, and the Load Balancer. It gives you a brief introduction about some of these and explains some of the details that we mentioned very briefly. Things like your Front Door works on layer 7 of OSI model, handling your HTTP, HTTPS traffic, whereas the Traffic Manager looks at DNS-based traffic, as mentioned before. Similarly, if you're looking at your Application Gateway, this manages, again, your layer 7 traffic, HTTP, HTTPS base, and manage them for you in your environment. However, if you're looking for just a solution that can handle TCP and UDP based traffic, then you can look at creating a load balancing solution in your environment by simply implementing a load balancer. However, this documentation has something very nice. If you scroll further down onto it, it has a very nice flowchart diagram that explains for you how to pick up one of these solutions, based on some of the decisions they can make. For instance, if we start going through this and talk about looking at my solution, so let's start this looking at web application, HTTPS, HTTP based. Well, maybe not. I'm not really looking at a web application. Well, is my solution going to be internet-facing application? Maybe it's not. In that case, just a load balancer would be good enough. However, if I change some of those settings, for example, it is going to be an internet-facing application, then I'm going to decide if it's a global deployment or if it's going to be in multiple regions. Then if that answer is a no, a load balancer is still good enough. If it's yes, then maybe I need two of them to work together as traffic manager to handle that DNS-based traffic and the load balancer in the backend to balance the load. However, we can carry on going through the tree in here and understand other pathways that I can choose depending on my needs and and different solutions that it would suggest that I might need to implement. Now, before we go into some more details on this, you might consider looking at this documentation and think and decide on the solutions that you need. However, it can be very easy for you if you land onto the Azure portal and within the search area, start typing in load balancer, and one of the options that the portal gives you is help me choose. Now, this is an amazing option to look at. Now, you can by all means go and refer back into the documentation to understand detailed information of what each one of those solutions are and decide looking at the flowchart diagram on what you need to work with, or you can simply come in here and click on help me choose. Now, if I zoom out just a little bit, you can see all the four options listed on the screen for us. And if I click on this service comparison, it gives me that brief overview around all of these services. For example, what protocols each one of these support. And if I want to understand what policies do they follow in terms of managing their data, in this case, or managing their workload. In this case, you can pick up different protocols or different routing policies that they follow. And I can also look at if there are certain security features that I might be interested in as part of implementing my solution and other features that are listed on the screen. So you can do a quick comparison between these solutions. Now, apart from that, if I want to go back into that flowchart diagram and understand which one I need to choose, then in that case, that's also built in as part of this setup. So I can always look at these questions and answer them. Does the application use HTTP or HTTPS? I can decide to say no at this stage. Then I can see it's reducing down the number of options I have. Is this application public or internet facing? If I say no, it might turn back and say you just need a load balancer and that should do the job for you, giving me a brief introduction onto what this does and how it works. And we can always go back a step and try and say maybe yes it does, and then it can ask me for the question, is it going to be in multiple regions? If I say yes, then it might suggest solutions like, hey, go and implement one. Apologies, let's take a step back and suggest no, and then it might suggest, hey, implement both of them as part of your solution, and it explains a little bit more around why you need both of those solutions in that case. I can always start over again and go back the tree and answer some of the questions just to get to the solution that I'm interested in as part of my setup. Now, once I've decided what solution works for me best, based on my needs and the kind of traffic that I'm balancing, I can go and implement them. Now, before we start implementing some of these in our environment, let's decide or discuss some more options that are probably important for us to look at so we can make some decisions wisely. Right. Now, before we start implementing our load balancer to look at how it works and what it does, one of the key things that you might want to understand is the difference between different types of load balancers. Now, if you're looking for a load balancer that is going to handle traffic for you that's coming over the internet and it's going to reach your resources and it's going to be handled by a load balancer, in this case, this is what we refer as a public load balancer. A public load balancer that would probably have a public IP address that it would require for it to connect. And it would then handle the traffic in the backend to the backend resources that you have. So a pool of resources that you've kept in the backend for it to handle. Now, in this scenario, if we consider us using multiple web services or web servers in the backend, and we're handling simply TCP port 80 traffic that's coming from the internet and landing onto my public IP address. In that case, my load balancer can then decide on shifting this traffic between the different resources that I have in the backend. Now, this is public facing simply because it's got public IP address and traffic lands onto this load balancer directly from that public IP address. Now, on the other hand, we could also look at a different solution that we refer as internal load balancer. Now, the naming on this is quite crucial to understand. Typically, you'll see either a public and private solution or internal and external solution. With the load balancers, we have a public load balancer and an internal load balancer. Now, the difference between an internal load balancer and a public load balancer is that the internal load balancer is designed to handle traffic internally between the resources that you have created in your environment. Now, in this scenario, you can see from multiple resources that I'm running in my backend pool to access some other resources like databases where they might be fetching some data. I am using another load balancer to handle that data for me. Now, typically as part of the entire solution, I might have the load balancer. This is me trying to draw a load balancer with my amazing drawing skills. But having a look at how a load balancer could be pointed at. And as we mentioned before, with a public IP address available to it and handling this traffic to all the resources. So this would be an implementation of an actual solution where traffic coming from over the internet might land into the public IP address. It handles that traffic based on my backend pool. And if the resources that are configured within the backend pool need access to some more resources like the database and fetch some information for the end user, in that case, we can use an internal load balancer in this scenario that can then simply dish out this particular request to a available database and fetch data from it. And again, in this way, it can balance that traffic for me in the backend. Now, this is a backend or an internal load balancer for me. Typically, you would not have traffic directly coming from internet or outside networks directly accessing my internal load balancer. Now, apart from understanding the public load balancer and internal load balancer, let's start creating a load balancer to cover some more details. Let's jump onto the portal to have a look at some of that. Now, I'm back onto my portal, and for this part of the session, we are going to start creating a load balancer. Let's start creating a load balancer. I'll zoom into the menu a little bit so we can see some details. Now, typically the basic details that we cover are usually looking at covering my subscription, my resource script that I'm going to use to implement some of these resources. So let's drop this into AZ104 demo and giving it a name. So let's call this load balancer 01 for this particular demo. Now I'll keep this resource in UK South. Now, when I go further down, I can see I have some solutions over here to look at a standard load balancer SKU, or I have an option to implement a gateway. Now, in this particular solution, we are not going to look at the gateway solution for now, so we'll leave it as a standard solution or SKU for us to work with. Now, when we go further down, I can see the options to choose from a public or internal load balancer. And for just this demo, we'll make it a public load balancer. So this is the first part of that diagram that we were looking at earlier on. So we're creating a public load balancer. So the traffic from the internet is landing onto a load balancer that can then balance the traffic onto my resources, such as some virtual machines in a backend pool for me. Now, as I go further down, I have an option to choose a regional or global solutions. Now, if I go back onto the slides where we were looking at talking about the different versions of load balancers, let's have a quick look at that slide one more time. Very quickly, if I point out the details over here, this particular slide mentioned about global availability and looking at some of the solutions. If we look at front door, as I mentioned, this is a content delivery network or the traffic manager, which resolves your DNS, which might need to divert traffic to different networks in different parts of the world, then you need global resources for both of these solutions. However, my application gateway and my load balancer currently doesn't show on this slide as global. But when I switch back onto my demo environment, here I have an option to choose for a regional resource or a global resource. Now, from the documentation, we know the load balancer is a regional service. So if I click on the global option here, this is where it provides me some more information to look at. Now, very briefly, clicking onto this link to understand why it is now also giving me an option to implement some of these solutions as a global service. Now, typically when we're looking at a global solution, that simply means that I'm able to configure these resources as a backend pool across different regions, as compared to regional solutions, as we covered in the networking sessions earlier, that these are not kept in the same region. Now, if I look at the solutions, currently this particular service is limited in certain regions. So it's not particularly available across all the regions that you're working on. So again, based on some of that limitation, it might be available in all regions in future. We don't know as yet. However, currently it's only available in certain regions. So something important to bear in mind. So again, since it's not fully available as a global service for all the regions, let's consider this as a regional service and limited global options available for it. This part of the demo, let's create it as a regional solution for us. Now, that's my basic tab completed. In the bottom of the screen, as you can see, we can click on front-end IP configuration. So that's the next tab that we have in our environment. Now, simply because we are creating a public-facing load balancer, it will be, again, useful for us to have a public IP address assigned to our resource. Simply, let's jump into that part and request for a public IP address. Now, in our networking module, we have had a discussion around assigning public IP addresses. So we are going to do something similar in here as well. So we are going to look at adding a front-end IP configuration. As part of this, let's say what the configuration name is. This is going to be config for my load balancer 01. And we are requesting for a IP version 4. And we're looking at an IP address, a public IP address for Azure to allocate to us. So we are requesting that. However, if you're looking for IP address prefixes, for instance, you're looking for a range of IP addresses that has same start and the matching addresses, or in a sequence IP addresses, for example, something that ends on .11 and the next one ends on .12. Again, no guarantees on what numbers you're going to get. But if you're looking for addresses that land into a sequence for you, you can go and request for IP prefix. However, for us, just an IP address for now would do. Now, we are going to request to create a public IP address. I can go and pick one of the ones that we created earlier on. So we can say demo public IP. This is something that we created as part of our networking session earlier in the course. So we can choose that. However, if I don't want to use this, I can simply hit create new, and it will take us through the same menu again in terms of creating that particular public IP. For now, we'll choose that public IP and we'll start creating that. Currently, it's asking me to implement a gateway load balancer. We'll leave that one off for now and say OK to this. Now, I've saved my front-end configuration for my load balancer as part of this setup. Now, for the next part of the configuration, you can choose to do these at the end. If you want to create your load balancer, just with those two settings, you can. So I can hit create and review straight away and then come back into this and configure some of those details. However, for this demo, let's carry on and do all the menus in the same go. Now, for the backend pool, these will be the resources that you're creating as part of the setup. Let's call this as a backend pool for my load balancer 01. Again, better naming convention will go a long way. Once we've got the name for the backend pool, we can go and choose the virtual network that we want to assign to this. Let's go and choose the hub VNet that we have. Now, I'm going to pick some of the details from here to suggest, hey, help me assign adding some of the resources that I have in my hub environment or hub virtual network and add them to the backend pool. Now let's go and add them. Now I can choose them by network interface card or their IP addresses, depending on what's easier for me. Now in my hub virtual network, I have two resources referred as backend server 1 and backend server 2. So I've got two of those resources running. So I can simply add both of them and bring them to the scenario. Now, one thing that's important to understand, this is a regional resource. It's not a global resource. So I can't bring in resources from other virtual networks in this environment or add them to this backend pool simply because this backend pool is looking at that virtual network where what I'm assigning to this resource. So for that reason, it will be limited for me to choose resources from other virtual networks in this scenario. Now, let's try bringing in a virtual machine from a different virtual network and try and see if we can add that to the resource. Now, if I choose the front-end server from another network and try add, you can see it's not taken some of those details as yet. Now, let's try one more time. Let's try go back into my hub network and try looking at adding them. Let's bring both of these servers and hit save this time to see if it will make any difference. So let's hit save. Now, currently it's added those two resources as part of my backend pool. If I hit add backend pool again and go and give a detail, now I can look at creating a new backend pool instead of amending the current one. So let's take a step back out. Let's cancel this part. And I can see currently that's my existing backend pool. Now, let's move further. Once we have the backend pool created, we are going to create a rule on how the traffic is going to be managed by this load balancer as this traffic hits the public IP address. What should it do with that traffic? Where should it send it? Now, as part of that, we'll need to configure some details. Let's define some backend rules for this. Now, one of the first things that we're going to do, we're going to give it a name. So let's call this my load balancer rule 01, just for this part of this session. My IP version that's looking at is IP version 4. Front-end IP address, we've just assigned a front-end IP address to it, so we'll go and choose that for now. The backend pool that we just assigned, we can go and choose that now and define, hey, if the traffic is landing onto this particular IP address, then the traffic should be sent to this backend pool that we are working on in our environment. Now, if you're adding more than one backend pool, you might need to create multiple rules defining on, hey, if the traffic comes to this, how it should handle. Now, as part of this setup, because we're creating a demo, let's assume this was for a web service or a web application, we'll need to define what traffic this is going to be and what port does it work on. So if I choose TCP port, TCP protocol, we need to define a port for web services, let's assume using HTTP port 80. Now my backend port, this is where the traffic lands onto my public IP address or front-end IP address on port 80. And as it leaves the load balancer to go to my resources sitting in the backend, I'll need to define a backend port. So we'll keep that same. So again, based on your requirement, you might have different settings, but for now, we'll keep the traffic on port 80 traveling through my setup. Now there are some other settings that we need to configure that are quite useful to understand. There is a setting for health probe. Currently, one doesn't exist. Now, this is an important setting that you should configure as part of your setup. Now, let's create this. While I create this, I'll talk about some more into details on what a health probe is. Now, typically, in the backend pool, if you're looking at a few resources, let's assume in my scenario, I'm adding 2 virtual machines to support the backend pool. Let's assume you have more than 2 resources. Let's assume you have 5, 10, 15 resources in your backend pool. Now, the job for the load balancer is to direct this traffic to manage the load coming in on your network. If one of the resources in the backend is down for whatever reason, you're either taking it down yourself or it has some sort of an error and it's restarting or shut down or is hung at some point, the traffic landing to that resource might never come back as a reply to the load balancer. Assume the user on a receiving end trying to type in a website or within a website, clicking on a link, now waiting for some sort of a response for a new page to load, and they're hitting refresh button and nothing's coming back. Now, this traffic, every time they request that information, goes to the load balancer. Now, if the load balancer is directing that traffic to that resource that's not working, they're not going to get a reply back from the load balancer simply because it's hung on that server. I'm hoping the load balancer will switch to another resource and keep on going. But if they're still waiting for that request to come back, then that request will die because that server is not responding to them. Now, to avoid certain situations, we can have something called a health probe. This health probe is going to probe that resource as part of the load balancer. It's going to probe that resource in the backend in the pool to ensure it's available. Hey, are you there? Are you still responding? Are you still responding? And it can check that based on the service you're working on. If this is a website, I'm using HTTP protocol port 80, so I can create the health probe on port 80, so it tests if port 80 responses are coming from the backend pool. So we'll create that. Let's call this health probe load balancer 01. Again, that's the name convention that I'm coming up with. I'll use the TCP protocol as the rest of my services are based on that. I'll leave port 80 because this is where I want to check that resource is my backend pool resources like virtual machines are responding to me on that. So if the traffic comes to it, it will respond back to me. Now in here, it suggests by default 5 seconds. Every 5 seconds, it'll probe that resource to say, hey, are you responding? Are you available? Are you going to respond? And it will keep on checking. Now, if it does not get a response back from that resource twice, it stops sending any requests that are landing onto the load balancer to that resource, pretending it is not part of the pool, and shift that load to other resources in the pool. However, if that resource comes back to life, because it doesn't stop probing for after it's taken out of the pool, it still keeps on doing that every 5 seconds, even if it's not responding. After the second successful response back from the resource, it brings that resource back into the pool so it can start sending out some requests to it as well. So again, we can use this time by default, like I said, it's 5 seconds. You can amend that based on your need in your environment. Now, let's go ahead and create this, and let's hit save and health probe. Apologies. Let's type this again. So we created health probe load balancer 01. I think I needed to hit save over here first before hitting the back save menu for the load balancer. So now we can see we have a new health probe being requested as part of the setup. So if I hit save onto this, it comes back as adding that setting there for me. Now my rule is ready. I am simply going to start creating this load balancer. Now I have an option for an outbound rule, but for this particular part of the session, I'll leave the outbound rule away from here and simply jump onto tags or hit create and review my resources. Now, typically this is pretty much everything that you need to know. It's come back with the validation is good. I can review the resource details that are on the screen to ensure I've got the right settings there, and I can hit create. Now, as a result, this should create me a load balancer with a pool in the backend to resort to. Now, once this is up, this is our load balancer up and running. We can have a quick look at this. As we can see, the settings already created for the load balancer that we just created. Let's go into looking at the front end public IP address for this resource. Let's take this IP address and try this out. Now, if I open a new tab and type in the IP address for this, this is landing me to my backend server 2 that's currently working in the backend. Now, if I try not going on to IIS server, and just for the test, let's try it in private browser and try that link one more time to see if it will land me onto the different server that we have, just to see it will split my load between the two. Not secure. Let's continue onto the site. There we go. So that's just a quick demo to show that it's load balancing between my connections, landing me onto backend server 2, backend server 1 as a switch between the settings. So again, this is a quick understanding that I have two resources in my backend pool, and these two resources are handling the traffic as and when they land onto the front-end public IP address. As an end user, you might be typing the same web link or a public IP address, and you land onto the public IP address of the load balancer. In the backend, it will then handle the traffic based on where it needs to go on one of the resources in the pool. Now, the health probe is here looking at ensuring that the backend pool resources are healthy and they are ready to respond to the queries that we are sending to the load balancer. And then again, looking at the rule that we've defined, simply telling the resource, hey, if there is a data coming onto this IP address, this is the backend pool for it on port 80, send it through in that manner. Now, very briefly, if I look at the insights, this is typically how currently my load balancer is configured, as explained earlier. So we have a public or load balancer that's configured with public IP address onto it. And in the backend, it has a rule suggesting that if the traffic lands onto this, it has a backend pool, and these are the resources that we are looking at in the backend pool. And currently, the green tick simply suggests that both of these resources are healthy. And typically, if I zoom out just a little bit, I should be able to see some details around the health status of these resources, and currently suggests it's currently healthy, and the health probe suggests they're 100% responding to the queries in both cases. So this is a quick overview to understand how currently my load balancer looks like. Now, if I look at this diagram, this is interesting to see how currently my resources are configured in my environment. Now, let's keep this diagram in mind, and let's move on to the next topic that we are going to discuss. And let's move away from load balancer to looking at another load balancing solution called application gateway. Now, application gateway is something very similar to what we discussed earlier on in terms of managing resources for me in my environment, handling the traffic coming into my resources. However, this time the load balancing solution called application gateway helps me balancing the load, not just based on TCP and UDP, but also be able to manage that looking at some protocols at layer 7, which is HTTP and HTTPS based traffic. Now, if you look at the diagram, this diagram looks very similar to the insight diagram that I showed you earlier on my load balancer. Now, one thing that's important to point out here is the difference between looking at this particular option that we did not have in our load balancer. Now, let's assume traffic coming in from a browser, from somewhere over the internet, landing onto my application gateway's public IP address. At some point, this is what we will have. And from there, in the backend, we have a part of the solution, an option that's called a listener. This listener is able to understand if this traffic is coming on any one of these protocols, and based on some of that information, it will pick up or decide a rule that it can choose to apply to that traffic. Now, at minimum, it needs at least one rule, just like we did in our load balancer, assign that if this is the public IP address, this would be the backend pool for it, and this is where the traffic will flow on, in our example, TCP port 80. However, in this particular case, we're looking at a rule that will assign some sort of HTTP based on HTTP settings or HTTPS settings, and deciding from there that the traffic will flow into backend pool. Now, based on some of this, we can look at a couple of different ways that we can configure our application gateway in our environment. Now, looking at two different scenarios, let's break them down one at a time. I have a solution that we can configure based on path-based routing. Now, the path-based routing could simply look at different web addresses. Like I said, it looks at my HTTP traffic and manages that data coming in. Let's assume at the user end, we have an application. And this application, let's assume, has two buttons in it. Again, just hypothetically thinking, one of the buttons has got information around images, and the other button over here has something to do with videos. Now, this is probably me providing a solution to my clients. If you need to go do image editing, go into my app, click on images, use image editing resources. If you want to go and work with video editing, go to my app, click on video, and you get access video editing resources. Now, video editing resources might consume a lot of different compute power, and I might need to implement a lot of different resources in the backend that can support the high-end graphic cards and can cater for their need. However, for my image editing, I might not require as extensive workload. So what I can do is I can choose to create two different set of pools to save cost or manage traffic differently. In this case, let's assume we create a set of pool for resources that can handle image editing and a pool of resources that can handle video editing for me. And as and when the users click on one of these links on the app or the website, typically the path that they will end up creating will be, let's assume, contoso.com. Let's say /images. Now, their path will still take them to the front end public IP address of this load balancer. Now, part of their access would mean that the front end load balancer, or the public IP address of this load balancer, will pick this information up. However, the part that's important to understand that differs this from a load balancer is that in the backend it has a listener. Now, this listener is able to understand the traffic that's coming in and the path that traffic is taking. And based on that, you could define different rules saying, hey, rule number 1, if the traffic is coming on a path that ends on images, then send this traffic to the resource pool that I have for images. Rule number 2, if there is a traffic coming on that ends on videos, then send this traffic to the pool that I have created for video resources. Now, in this case, depending on the path the user takes to reach the backend resources, they will land into different pools and utilize their resources and carry on working in this scenario. So this is one example of me using an application gateway, using path-based routing. Similar to this, we can also consider using this in a different manner called multiple site routing. Now, for multiple site routing, let's assume for this example, we are not using one particular site, we're using multiple sites. A site like contoso.com and fabricam.com. Now, I could have multiple team members. Let's assume I have two different departments. One works as part of Contoso organization, another department that works as part of Fabricam organization, and they're part of my entire company. Now, let's assume I have a user that sits over here that's part of Fabricam. I have a user here that's part of Contoso. Now, for them to access their resources, let's assume their internal portal, their discount facilities, promotional sites, anything that you can imagine. So for them to type or get to that, they will typically type in the company's domain details as contoso.com or fabricam.com. Now, if that was the case, in both scenarios, we can make both of these addresses land onto the same public IP address of my load balancer, in this case, the application gateway. Again, in the backend, we have the listener that sits over here and is listening to the traffic coming in, again, HTTPS based traffic. And this listener is able to pick this information up, and based on some of that, it can say, let's look at different rules that we can define at this point. If this traffic is coming for Fabricam, let's push this traffic to the backend pool that shows information that's related to fabricam.com. Or if this traffic is coming for contoso.com, then push this to a complete different pool that might show them complete different site or different variation of their internal portal with different discounts, different access, or whatever that need may be for them to look at. Again, in this case, we are doing a multiple site routing in this environment. Now with this, we're coming to a close with load balancing solutions. However, let's move on to talking about a very, very interesting tool called Network Watcher. Now, Network Watcher is an amazing troubleshooting and diagnostic tool that you can use for networking resources. There are quite a few different features available within Network Watcher. However, we are not going to look at covering every single one of them in this particular module or in this course. We've had a brief look at part of Network Watcher in one of the previous modules, talking about network topology. So let's make a start at network topology one more time. Let's jump into the portal and have a look at it. All right, we're back into the portal and we are simply jumping into Network Watcher. Now, we've earlier on explored in the previous module to understand how my current setup looked like using topology. Let's go back into topology one more time to see if you see anything different. Now, if you haven't seen the previous module, by all means go and have a look so you can compare the differences yourself. Now, what I'm going to do is I am going to explore one of my regions to see what resources live within. And as part of that setup, now we can have a quick look at some of the resources that we were working on in my previous modules when we were talking about virtual network peering. Before we created the peer, when we were exploring some of these topologies in the module, we could see that there were multiple networks available for me to look at. However, now I can see a better representation of an hub and spoke topology within this. I can see this as a hub simply because it's got two different spokes connected to it. So I can see VNet A and VNet B are connected to the hub and they're paired. Now, if I zoom into this a little bit more, you can see there's a 2 written somewhere over here. Again, appreciate this is very, very small. Hoping you can pick this up and you can see there's 2. Now that's simply telling me that's two-way connection between that resource. So the traffic flows back and forth from both of these, between both of these virtual networks. So I'm hoping that makes sense. Now, I do have some other virtual networks over here as well. So you can see there's a load balancer that we created. So we can go into some more details around the load balancer to understand what resources are configured within that. So again, this is a very, very nice tool to look at exploring details visually representing your network settings. An amazing tool for you to understand how things are configured in your environment, simply because it's very interactive for you to click on and explore between your resources if you wanted to look at how currently your setup looks like. For instance, let's go into my hub setup one more time, and if I explore some more into how my hub looks like, I can do that. In fact, we could just hover onto it to get a quick overview, but now we're just waiting for it to load for some more details. All right, it's loaded with some more details onto my hub. As you can see, I can look at the 2 different connections, which I can expand further between the 2 other networks that I have. So if I hover onto them, I can see a quick overview of what they are, where they are. I can go into more details. I can expand that and look at more details. Now, the expanded version of that would look a little bit like this. And in this case, I can look at a subnet that I have in here and an NSG that's applied at the subnet level. I can expand that further to see some resources in here. I can currently see I have a backend server 2. I have a backend server 1 running in here. Each one of them has a network interface card. Obviously, you can follow the track to see exactly what details they have. And I have network security group that's applied to one of the network interface cards here. And you can follow another network security group that's applied to another network interface card. Now again, the configuration of these could be completely different in your environment. You can choose one and apply to both, and it's entirely up to you. Now, this is a very, very nice way of visually seeing how things are, rather than jumping through your menus and finding out what configuration is done where. We can jump into those settings right from here to go and change if we wanted to look at some other settings. Now, that's one part of Network Watcher, as we can see our resources visually. Apart from that, let's talk about a little bit more into network diagnostic options, rather than looking at the monitoring option, which we were looking at for topologies. One of the tools that I have here is called IP Flow Verify. Now, for this is a nice tool for me to check if the traffic is going to flow into a resource that I'm looking to connect into. Either you're doing this to ensure once the traffic arrives, it will connect well, or you're currently facing an issue where you're getting some error messages or it's not connecting and you want to verify why is that the case. Now, this could be a first step in checking some of those things. Let's do a quick check on this. Let's pick one of the resources that I have running in my environment. So let's, for example, go and say my backend server that I have created. Let's pick up the network interface card for it. A resource can have more than one network interface card. Again, we'll look at some more details of that in the next module. Now, currently, I'm looking at a protocol that's based on TCP, traffic coming inbound to that network interface card, not going out of it for now. We can check either or. The local IP address of that is currently this. Now, what I want to do is type in a local port. So I want to test this out on port 80 as if I was sending traffic on a web server. This is the backend pool that we were using from our resource as part of the load balancer as well. Now, from remote IP, this can be any IP address that you have in your environment. Now, what I am going to do is I am going to choose one of the IP addresses for one of the other servers that we have. So let's try 10.7.0.4. That's another one of the servers that I've got connected at the moment in my environment. And the backend, the remote port that traffic is coming from is going to be 80. In this, I'm checking if my remote server, that's 10.7.0.4, is able to connect to the backend server that I'm looking at, which is at 10.6.0.4. And that's what I want to verify. Now, let's try this. Now, beauty of using IP flow verifier is it'll show me the flow of traffic from one resource to another. It's a nice way of checking if there are any issues in terms of your connectivity. And along with this, it will tell you if there's any blocking of traffic based on some of your security settings. For instance, in this case, it suggests that traffic is currently allowed and also shows me a security rule that allows or denies that traffic. Now, if there was a denied traffic available here, it should tell me what rule is denying that traffic. Currently, it suggests that I have a network security group called backend server 1 NSG, and within that, there's a rule called allow any HTTP inbound traffic. So based on that rule, this traffic will flow through. Now, if I was to try, let's assume we are testing a different port. So I have HTTPS traffic coming through. I want to check if this will be catered for me in this scenario. Now, while we are trying to do port 443, which is for HTTPS, and we hit verify flow. Now, I haven't configured the HTTPS between these two servers, and I haven't added that onto my NSG. Ideally, I'll assume this will be blocked. I can see its access is allowed. However, if you look carefully to understand exactly why this is allowed, this is my 65,000 rule that's connected within my NSGs by default, which is allow traffic within the VNet inbound. Remember, these virtual networks that we have, they are paired together. So traffic between these virtual networks is not going to be blocked as from the NSG as the setup that we've created. However, if I change this virtual network to a complete different network that I have, let's jump onto a complete different network and then try this traffic from a network that is not paired with this particular network. Let's try that one more time, see what will happen in this time. Now, hoping this time it would give me an error message suggesting that this traffic isn't allowed. Simply because I know there is no connection between the two networks. So if a traffic from that server is going to go and connect to that other server that I have, it is not going to go through. And particularly in this case, it's suggesting me with a rule that says deny all rule. Now, again, going back to the networking session where we discussed NSGs, I did mention that if you ever see an error message for deny all inbound, this is the very, very last rule on the stack of NSGs suggesting that you haven't created a rule. So in this case, my remote IP very likely doesn't have a rule created for my resources. In this case, doesn't have a rule created for 443. So it's going down the stack and it's hitting the bottom of the list and suggesting can't find, and reaching down to 65,500 rule, which says deny all other traffic. So we need to simply go into your settings here and configure that rule so the traffic can be allowed. Now, again, it's a nice way to check if the traffic will flow rather than me picking up a phone and checking or sending an email or IM to my clients or my users to suggest, check now, is it working? Check now, I've changed some settings. Check now, I've created a rule. So all I can do is go and modify some of the rules that I require, come back in here to check from the source to destination if the traffic will flow. If in a resource that I have traffic coming from a remote location, will it reach my the destination I have in my setup, or vice versa? Will it work? And if it does, then what rules are hitting, allowing it? And if it isn't, what is blocking that traffic from coming in? Now, one last option we'll check as part of this module into my Network Watcher tool, and this is going to be looking at my next hop. Now, in one of the previous modules, we were creating user-defined routes, and part of that, we created a transitive traffic from one of my spokes, jumping onto my hub and going back to a different spoke, which we created as part of the virtual network peering. Now, if you haven't seen that video, please go back and watch some of those details as we create the demo of different virtual networks and pairing them, and also create a jump from resources using a virtual network appliance and a user-defined routes, and sending the traffic from one spoke to another spoke without having a direct pair between the two. Now, in this part of the session, we can go and test if that is the case. Is my user-defined route working? And of that module, we had a look at the routing table to see there was an entry made within that as a user-defined route entry, that if the traffic was going into that network from this resource, what path should it take? Now let's verify that by testing if the traffic is going to that resource first and if it's taking the right route. Now, for me to do this, let's start working with some of the settings on the portal. Now, I've chosen my subscription already, resource group. Let's switch the resource group to the resource group that we're working on in this course, and simply choosing the resources. Now, I have a backend server as my hub that we have working with, so we want to change some of that. We want to look at if front end 1 server can speak to front end 2, which are in complete different spokes. That's in spoke 1, that's in spoke 2, both connected to a hub, which is a backend server. So let's try that. So from front end 1, that's the detail on the front end server. That's the source IP address of my front end server. Let's just verify that my details on my backend server is correct. So if I am jumping on the right network, so let's try my backend server one more time, checking the network identity just to make sure that we don't land onto the wrong server. So that's the IP address for that. So let's take some of that out from here and jump back onto the portal where we are and type some details in there. So this is, apologies, that is the hub. Apologies, we're testing the connection between two spokes, Waleed. What are we doing? All right, let's jump back onto this. So let's have a quick look. Let's jump the traffic between the two front end resources and let's have a quick look at that. So front end 2, and I'm picking up the IP address of this particular resource, not the backend. That's my next hop. That's the response we should see. All right, let's try that. Now, let's clarify some things over here. What I'm trying to look at as part of the setup that we did in the previous module, we have a hub network. Apologies if my cursor plays well. So we have a hub and spoke topology like this. We have resources working in my hub, which is over here. I have a resource that's called backend server in here. I have a resource here that's called front end server that we are looking at here. And I have another spoke or spoke 2 where I have a front end server 2 that is connected here. Now, what we're trying to do is have a communication between these two resources. However, we don't want them to have that direct connection going through here. We want this traffic to jump onto my NVA, which is a server that I've created here, and have a transited traffic going onto the front end server too. I'm hoping this makes sense. Now, please go and visit the previous video to understand what we created, just in case if this is a little confusing for you to understand. Now, as a result, what we are trying to get from this next hop is to ensure that the user-defined route that we created, suggesting that, hey, if this traffic comes onto you from server 1, aiming to reach server 2, please forward this in that direction. So we created a user-defined route for it. Now we're just checking if that route in this case is working fine, and we should see the next hop is our backend server's IP address. Now let's check the next hop. Now, as the results are back, I can see the result is suggesting that the next hop is a virtual appliance, the virtual appliance that we have running in our backend pool. So this is the IP address of that resource, and it's using the routing table that we've got created in the backend, and it's using the route table that we defined as part of our setup. And if you look carefully in some of the details as part of this, let me hover onto that again. Okay, let's try scrolling this through. And if I can highlight some of the details right here. So we created a routing table called hub and spoke. We created a route, user-defined route called hub and spoke. As you can see, suggesting that it's based on that route that we created. It's letting the traffic go from one resource to another, jumping onto a virtual network appliance that lives in that network. So I'm hoping that makes sense. Again, by all means, if you want to relate this back onto the part of the demo that we did in the previous session, this is just another test to ensure the traffic is flowing and if it's taking the right path. In the previous module, we had a look at the user-defined route that was available in the routing table to confirm the same settings, but in this case, we're actually sending a traffic to test if it's actually taking that path. Now, with this, we come to the end of this module. In this module, we covered the key aspects of administering network traffic in Azure. We began with an introduction to Azure Load Balancing Solution and spoke about load balancers. Next, we explored Azure Application Gateway, focusing on its role in balancing web service traffic and HTTP/HTTPS traffic. Finally, we concluded with an overview of Azure Network Watcher, emphasizing its capabilities in monitoring and troubleshooting Azure network infrastructure, addressing network security and connectivity issues. I encourage everyone to continue learning and remember to utilize the resources and knowledge check questions provided on Microsoft Learn using aka.ms/learn to reinforce your learning. Thank you for your participation, and we look forward to seeing you in the next session.